Unit 5 polynomials, 5e, is write a polynomial function when we get given the x-intercepts. So, looking at the x-intercepts of this graph, they're at 4, x equals 4, and x equals 0. So, x equals 0, and x equals 4. To come up with those x-intercepts from the actual given equation, the given function, one easy way to do this is by factoring. So if I factor out an x, and then I set each factor equal to 0, so first factor x, set that equal to 0, and x minus 4 equals to 0, and I solve for x on both of them, I end up with x equals 4, and this is already solved for x equals 0, so that's x equals 0, which end up being our x-intercepts. So when we're writing a polynomial function, so we're writing out the polynomial from the given x-intercepts, we're going to work backwards from this. So the first thing we're going to do is set each x-intercept equal to 0. So x equals 1, x equals negative 1/3, x equals negative 5. And then we're going to work backwards from there. So to make it, we're going to have the factors all equal 0. So to make them equal 0, the first one here, easy, just subtract 1. And we have x minus 1 equals 0. So x minus 1 is one of my factors. And then we have, with a fraction, we're going to start out the exact same way. So x plus 1/3 equals 0. With factors, we don't have fractions. So to get rid of the fraction, anytime you have a fraction in an equation, you can multiply the whole fraction. Actually, it's 0 included. 3 times x, 3x. 3 times 1/3 is 1. And then 3 times 0, we do have to balance the equation, so you should multiply everything by it. 3 times 0 is 0. So now we have no fractions, and our other factor is 3x plus 1. So our first factor was x minus 1, and it's 3x plus 1. And the last one, just add 5. And you get x plus 5 equals 0. And that is your last factor. So to write a polynomial function for this, we're just going to put f of x equals x minus 1 times 3x plus 1 times x plus 5. This is in factored form now. And if I actually want to write out the whole polynomial, I'd have to multiply it out. So to multiply it out, to be in polynomial form, you take two factors and multiply them together. So what I do is I just put a little line here to just kind of focus my attention on the first two factors. So I do x times 3x, 3x squared, x times 1, that's not a very good line, x times 1 is x, negative 1 times 3 is negative 3x, negative 1 times 1 is negative 1, so that's it'll end up being a trinomial from the two binomials. I'm going to simplify that a little bit further. 3x squared, x minus 3x is a negative 2x minus 1, and then we have x plus 5. So multiplying this out now one more time, it is triple distribution. So we're distributing the 3x squared times x, 3x to the third, 3x squared times 5, 15x squared, negative 2x times x, minus 2x squared, negative 2x times 5, negative 10x, negative 1 times x, negative 1 times 5, negative 5. Let's put like terms together, and then we have our polynomial function. So f of x equals, there's only one term with a cube. We have two terms with a square, so adding, we have 13x squared. Two terms with degree 1, and that's negative 11x and minus 5. If you were to graph this polynomial function, it will have all three x-intercepts of x equals 1, x equals negative 1/3, and x equals negative 5. So, moving on. Now we're going to write the polynomial function given the x-intercepts of 3/2, 2i, and negative 2i. So now we're going to introduce imaginaries. So we're going to start with the exact same way. Set each x-intercept equal to x. We're going to solve for each one, make them equal to 0. So subtracting 3/2 from both sides of the equation. And then we have to multiply everything, both sides of the equations, by, I just multiply by the denominator. Multiply by 2, distribute it in, we get 2x minus 3 equals 0. So 2x minus 3 is one of my factors. Subtract 2i on my next factor to make it equal 0. X minus 2i equals 0. So x minus 2i is another factor of mine. And then over here we have add 2i. We have x plus 2i equals 0. So let's put these together. You can choose f of x, g of x, doesn't matter. I'm just going to go with g of x this time. Equals, setting all the factors equal to each other. This time, what I'm going to do is I'm going to multiply out the second two factors first. It does not matter. It's a commutative property of multiplication, which factors you multiply together first. You don't have to multiply left to right. You can multiply any you want. The reason why I'm multiplying these two is because they both have imaginaries. And I'm hoping that by multiplying them out, the imaginaries will go away. I can simplify a little bit easier. So, we have g of x equals 2x minus 3. Then let's start multiplying it out. X times x, x squared, x times 2i is a positive 2ix. Negative 2i times x is a negative 2ix. And a negative 2i times 2i is a negative 4i squared. So I'm going to simplify this a little bit more. So the next step, g of x equals 2x minus 3. Now we have x squared, 2ix minus 2ix. Those are going to equal 0. I squared, anytime you see an I squared, that is equivalent to negative 1. So we have negative 4 times negative 1 is a positive 4. And now I'm down to just x squared plus 4. Sweet. I's all canceled out. So now one more step, one more multiplication. Multiply both of these binomials, 2x times x squared, 2x to the third, 2x times 4. And you can always, if you don't want to multiply it out to how I am with double distribution or triple distribution like in the last problem, you can certainly use box method, Punnett square. That works just as well. Minus 12. Gathering like terms, there happens to be no like terms, but I'm going to write from biggest degree term to the smallest degree term. So 2x to the third, degree 3 to degree 2, to 8x to the first, so plus 8x, and subtracting 12. If I were to graph this polynomial, it will have an x-intercept at 3/2, and then there'll be two imaginary that obviously we cannot see, but two imaginary zeros also.